Your phone notification chimes, and before you can process the sound, your hand has already reached out to grab the device. It happens with sound, too. A single chord of a song from a decade ago can trigger an involuntary wave of nostalgia, shifting your emotional state in seconds. We operate under the assumption that our choices are ours alone, that every action is driven by a conscious, internal thought process. But behaviorism suggests that internal thoughts are irrelevant to the study of psychology. This school of thought argues that every human action is a learned response to a specific environmental trigger. From this perspective, the environment is the programmer, and our daily actions are the execution of the code it has written for us. This lack of control, like the impulse to check a notification, is rooted in the mechanics of classical conditioning. Ivan Pavlov discovered that basic biological reflexes could be hijacked. By using a bell, he proved that a dog's physical response could be triggered by a completely unrelated sound. This chart illustrates that mechanism. Repeatedly pair a neutral stimulus with a meaningful event, and you create an automatic reflex. Pavlov's bells evolved into modern notifications. Your brain treats that sound as meaningful, triggering a response before you think. John B. Watson took this further, demonstrating that even complex human emotions, including fear, could be engineered through repetitive pairing. These experiments suggest that many of our gut feelings and visceral urges are not part of our personality, but are instead trained reflexes developed through our history with the world. Beyond these automatic reflexes, we perform intentional actions, complex tasks that require effort and purpose. B.F. Skinner argued that even these intentional behaviors are shaped by a rigid logic. They are dictated by the consequences following them. He called this operant conditioning, a system where we learn how to act based on the feedback the environment provides. The most effective tool in this system is reinforcement. When a behavior leads to a reward, the frequency of that action increases. Conversely, punishment uses negative consequences to decrease behavior frequency, pruning away actions leading to pain. Skinner used these clinical, enclosed environments to prove that by controlling every reward and penalty, he could precisely dictate an animal's choices. These findings imply that our own decisions follow a similar path of historical calculation. If every choice is a move toward the path of highest previous reward, independent free will becomes a difficult claim to sustain. This theory presents humans as machines, suggesting we could be programmed as reliably as any computer. But this view has a significant blind spot. It ignores the internal mental processes, the quiet reflection and abstract thinking occurring between a trigger and a response. Behaviorism struggles to explain how people solve complex problems through imagination alone, or why different individuals react to the same reward in completely different ways. While our environment applies immense pressure on our actions, our internal mental landscape ensures we are complex thinkers, shaped but not entirely defined by the reactions we display to the world. Despite these philosophical limits, understanding conditioning provides a powerful set of tools for self-improvement and education. Many of our effective learning environments, like schools, rely on these principles of repetition and immediate feedback to help us build and retain difficult skills. You can apply these same methods to your own life. By consciously rewarding your progress, you can build positive habits and reclaim your focus from the algorithms that compete for your attention. By decoding the mechanics of conditioning, we begin to see the invisible strings of our environment. We can finally stop reacting to the world and start designing the settings that shape who we become.